Okay. So we're going to have nonlinear systems of equations. So let's say that we have a line intersecting a circle. How many ways could a line intersect a circle? Here's a circle. How many ways could a line go through that? A lot. What's the minimum amount? Does it have to touch? No, it could be like out here, right? Those don't touch. So it could have no solution. Could it touch just once? Yeah, it could be like, that's called tangent. You remember that? So it could have one solution. One solution. Could it touch more than once? Yeah, touch it twice. It can just like go straight through it. Two solutions. Any more than two? Can it go 3 times? You're picturing it in your head. I can see the wheels turning. You haven't had all your caffeine yet. I know. It's okay. Some of you are in a sugar coma because you went over to the pancake breakfast. Can it touch 3 times? No, it can't. Not unless that line somehow turns back, and then it's not a line anymore. So in our regular plane geometry that we do, it can't have more than 2 solutions. And that would be the same for a line and an ellipse. A line, ellipse, it's going to be the same. If I have an ellipse, it could not touch it. It could touch it once. Or it could go right through it, touch 2 times. How about a line and a parabola? Could it have no solution? What would a no solution look like? Yep, just out here somewhere. Not touching you. Not touching you. Not touching you. Could I have one solution? It could. It could just touch it right there. I'm going to draw this one the other way because we are going to have parabolas that go sideways today. Can that have 2 solutions? Yep. Let's talk about a circle and an ellipse for just a second. How many possible solutions could you have with that? Can you have a no solution with a circle and an ellipse? Yeah, you can. And you actually can lots of different ways. Like they could just be side by side. Or you could have a circle so big that it has an ellipse inside of it. They don't actually touch. Kind of looks like an egg. Or the other way around. You could have an ellipse so big that it just has a circle inside of it. So you could have no solution. Can they have one solution? Yeah, they could be tangent to each other. You could have your circle, and then you could have like an ellipse right here, just barely touching it. That's not the only one solution. You could have a circle and then an ellipse on the inside that just touches it right there. How many solutions could you have? What's the maximum number of solutions you could have with a circle and an ellipse? 4. You could go all the way up to 4 solutions with a circle and an ellipse. If you had a circle and then you had an ellipse, it just went right there. You've got 1, 2, 3, 4 solutions. I'll say a maximum number of distinct solutions. 4 solutions right there. Think about a hyperbola and an ellipse. What's the minimum? No solutions, right? What's the maximum? What's the maximum number of solutions you could have? An ellipse or a circle? 4. If you think about it for just a second, on those lines, a line with a quadratic, even if it has an x squared and a y squared, you're going to get a max of 2 because the line only has that 1 power of x and that 1 power of y. But then when you get to like a circle and an ellipse, x is being squared and y is being squared. So that opens up the possibility of more solutions that can happen. Bless you. So when you think about the actual equations and the powers and everything, that gives you another reason why you can have so many different solutions. All right, so let's actually look at one of these. I think substitution is going to be the way to go on this one. Alright, I have a quadratic and a line. This is a parabola and a line, so it can have up to 2 points of intersection. I think substitution is the way to go because it already tells me what y equals right here. So I can just take this, put it in right there. So I have 3x minus x squared minus x minus 1 equals 4, which turns into 3x minus x squared plus x plus 1 equals 4. Clean it up a little bit. Do a couple of things here. I'm going to move the 4 over, and then because I don't like having a lead coefficient that's negative, I'm going to change the sign of everything. Alright, how do you solve a quadratic? Factor. So do you have 2 numbers when multiplied equal 3 and when added equal negative 4? Negative 1 and 1. Yep. So x is 1 and x is 3. If x is 1, remember y equals x squared minus x minus 1. So what's y? What's 1 minus 1 minus 1? Negative 1. And 3 squared minus 3 minus 1. What's 9 minus 3 minus 1? So our answers are 1, negative 1, and 3, 5. Alright, I'm going to graph this and this. 3x minus 4 x squared minus x minus 1 windows off. We'll fix it. Alright, so I can see they intersect 2 times right in here somewhere. I think I'm going to try to zoom in on that area. Let me adjust my window. I think I'll do an x minimum of -3. Maybe an x maximum of 7. Y minimum of -3 and 7. Now let's look at it. Alright, now I can more clearly see where they intersect, which is good because now I can use my calculator. So here's what I'm going to do. I'm going to tell it that I want to find out where they intersect like we did yesterday. But see how there's 2 intersections? It's going to pick the one that you're closest to. So while that's still my first curve, y1, that's still my first curve, I'm going to get close to that one. And I'm going to scoot over and get close to that one, and it tells me that that point is 3, 5, which I have right there. Okay, I'm going to do it again, but this time I'm going to go down here. That's my first curve. That's my second curve, and that point is 1, -1. So you can do this on your calculator if it's y equals. If it's, and this one's pretty easy. Probably getting that in y equals is easier than doing all of this and then just getting it on your calculator. So if you can get it to y equals, you can do it on your calculator. Now what's the problem with getting like an ellipse to y equals or a circle? What's happening to y in an ellipse or a circle? It's squared. So you have to do this. It's possible, but it's kind of a pain. Because you have to say, okay, if I solve for y, then you have to graph the top part as a positive square root and the bottom part as a negative square root. It's possible, but it's probably easier just to do it on paper. But if you come up with something like this, or if they're both y equals, which I think a few of them in your homework are, just do it on your calculator. I mean, the calculator, I don't suggest graphing when it's by hand because it's only as accurate as you are. But the calculator is really good at graphing, and they're really good guessers. So that's what I would go with. All right, let's look at another example. Let's try something else, something a little tougher. Oh yeah, let's do 4x squared plus 3y squared equals 48. And 3x squared plus 2y squared equals 35. So it looks like we've got a couple of ellipses here. What do you think would be easier to do here? Substitution, elimination, or graphing? Elimination, yes. Those are in standard form. Everything's lined up. Let's eliminate something. What would you like to eliminate? X's. Always. So multiply that one by -3. Multiply that one by 4. Negative 12x squared minus 9y squared equals, let's see, what is that? Negative 144? Somebody better check me on that one. It is? Okay. So then that's 12x squared plus 8y squared equals 1 150? 140. Okay. All right. So these cancel out. I have a negative y squared equals a negative 4, or y squared equals 4. Now this is something to be careful about. When you take that square root, remember y equals two things. It equals plus or minus 2. It equals a positive 2 and it equals a negative 2. So we have to put this in twice, okay? And then when we solve for x, we're probably going to get two answers from that one also, all right? So let's say we put, which one do you want to put it in, the top one or the bottom one? Bottom? Okay. 3x squared plus 2 times 2 squared equals 35. And then just so I don't forget, because there's going to be a lot of steps here, just so I don't think, hey, I'm done, but I'm not done, I'm going to go ahead and set that one up over there so I know there's still some more to do. Okay? So 2 squared is 4. And 4 times 2 is 8, right? So I have 3x squared plus 8 equals 35. Subtract 8. 3x squared equals 27. Divide by 3. Take the square root. X equals plus or minus 3. So I have two answers that go with that 2. I have 2, 3, and 2, negative 3. I'm going to let you catch up because I'm going to ask you some questions in just a second. So I'll just wait a second and let you catch up. I hear a lot of writing. Okay, is this one right here, is this one going to yield any different kind of answer? What's going to happen when I square a negative 2? It's going to become positive, and then I'm going to have exactly what I had over here, right? So you really don't have to do a lot of work with this one. You just need to, I'm telling you, it's a really good idea to write it down right away because there's so many steps in these problems you're going to forget. And you're going to be like, I'm done because I've done 1,000 things, so I have to be finished. But you're not really finished because you have to do 1,001 things. So even though the answer's not going to be any different, you're going to come up with this answer down here. I highly suggest you go ahead and write it down just to help you remember. So this is going to end up with x being positive or negative 3 again. So then we've got two more answers. We have negative 2 with a positive 3 and negative 2 with a negative 3. And all four of those are our answers. Let me show you real quick what a no solution might look like, and then I'll let you work on your work, or get started on your work. All right, probably, well, what do you want to eliminate here? What do you want to get rid of? The x's? All right, so if I multiply this by negative 4, let me just rewrite the top one. when I divide this by 13, I'm going to have y squared equals a negative number. Is that a thing? Is that a real solution? No. So this is non-real solution. So this has no solution. If you come up with something that just couldn't be, then that's a no solution. Alright, so let's look at your practice pages that I have. They're in Google Classroom. They're posted in Google Classroom. They're labeled 6-3 in Google Classroom. Right here. Alright, so let's start with number 1. And let's go to 31, doing every other odd. Now if you'll notice on these, they're not pretty. You're going to have to do something to these before you can start eliminating stuff. But you only have a couple of those. A lot of these are set up as y equals. So you can, or you can set them up as y equals pretty easily. So you can use your calculator. But 1 to 31, doing every other odd. And again, this is in Classroom. This has been posted in Google Classroom.